Congratulations, you made it. This is episode 3. We are still at Space Symposium, continuing with discussions with some space experts. So here we go. With me, I have Sal Alfano, retired Air Force colonel. Sal was an instructor flight instructor back in the days. You went to the academy grad. You've done tons of great things in your career, but what we're here to talk about today is CA. You've been working on CA for about 20 plus years, so I could probably say you're one of the experts in that field. And by CA, it's been called many different things. It can mean close approach, it can mean conjunction assessment, collision avoidance. So it's all kind of the same thing. Now, which one do you prefer to call it?
Well, if it's a collision that you're trying to avoid, then you have the two hard bodies, the spacecraft bodies actually touching each other. If it's a conjunction, it just means they come close. I prefer conjunction.
Gotcha. So how do you calculate this? How do you figure out, what are the early ways that you did it? What are the more modern ways that you figure out if things are going to have a close approach?
First thing you look at is you propagate both orbits until you get to the closest distance, the time of closest approach. You can use Cartesian misdistance in that case. You can use, put a keep out area around it, maybe a sphere or something that looks like a pizza box, and anything that enters that is considered a threat to you. You can use, if you have the uncertainty of the positions, you can use something called Mahalanobis misdistance, which basically, instead of telling you you're going to miss...
Say that again?
Yeah, Mahalanobis misdistance.
Okay.
Indian mathematician in the 1920s. But rather than use Cartesian misdistance, like I'm going to miss by 100 meters, I'm going to miss by 1 sigma, or 2 sigma. So you use sigma, you're in a sigma space as opposed to a physical Cartesian space. You can use probability, but for probability you need even more information. I need to know the size of the objects.
Ladies and gentlemen, the exhibit center and pavilion will close in 20 minutes. This is the last call for refreshments. To repeat,
probability, you need the misdistance, you need the object size. If you had orientation, that would be even better, but right now we just treat them as spheres because we don't know the orientation. And then again, you need the uncertainty of the position, which we call covariance. And you combine those all together and you can come up with a probability of a conjunction.
Can you go into the covariance a little bit? How do you calculate the covariance accurately?
You have to know how good your sensors are. In other words, how well they can see something. So each sensor, as it contributes, it's also contributing an uncertainty. And then mathematically, you can combine all those together along with the satellite track itself, which has its own uncertainty, and fuse all that data together to end up with an overall uncertainty. And then you use that uncertainty at that what we call epoch time, the time that you took a look. And then you propagate it forward, and that covariance will grow. The further you go in time, the less likely you are to know where you really are. So the uncertainty will grow with time.
So what are some things that people can do? What are some tools that are out there or services that are out there that you know about?
We offer some free tools, actually. One of them is called Socrates, a satellite orbit conjunction report assessing threatening encounters in space. Socrates. You can go to celestetrack.com, Socrates, and every day we take a look at all the public two-line element sets. We bring them in. We look at any pairing between active satellites and the rest of the catalog that will come within 5 kilometers of each other. And then we report those. We give you the misdistance, we give you the maximum probability, we give you the time that you enter a 5 kilometer zone, the time that you exit a 5 kilometer zone. And I just looked before we started this video, and we've got over 27,500 pairings that we're predicting to come within 5 kilometers over the next 7 days.
Wow.
But it's free. The service is free.
That's a big number. So in the future, when you start doing these predictions and there's commercial satellite constellations planned in the thousands. And if you're too conservative with your keep out zones, you're just going to be even more inundated with close approach warnings.
Obviously, the bigger you make the zone, the more conjunctions you're going to get.
How do you think the industry is going to deal with that?
I hope they deal with it very cleverly. They're going to have to monitor what they do. The better the data, the better the assessment. So if I have really good data, maybe I don't need a 5 kilometer keep out zone, maybe I go down to 1 kilometer because I really trust the data that I have. The way you can do that, we use general perturbations, which is two-line element sets. We use special perturbations, which is more accurate data. but the owners know where their satellites are. So if they're going to put up all these constellations, it would be nice to fuse all that data together, the observations that we're getting, plus their own data, because they know precisely where their satellites are. Most of them will probably have GPS trackers on them and that sort of thing. So that would be optimal, to fuse all that data together, really nail down those positions, and reduce the number of false alarms.
So what you're saying is we need some really good SSA.
Yes.
And when everybody's
exactly.
sharing and fusing their
Yes.
data. Gotcha. So back in 2009, there was the Iridium Cosmos collision.
Yes.
And I know TS, I was talking to him earlier about that, and the Socrates program predicted that.
Well,
not to say it was going to be a collision, hard-body collision, but based on the last look, and like you said, the unknown grows since you last saw it, it was in the list of things that could happen that week. Was it a week?
Right, it was within, actually it was within a second of the actual collision.
Okay.
And we were predicting less than a 700-meter conjunction.
Which normally would be fine.
Right, the problem with that was, after the observation, the last observation, remember then we propagate. After that last observation, Iridium maneuvered. So we couldn't see the maneuver and predict its new position. And it turned out they maneuvered right into Cosmos. In addition to Socrates, we also have something called the NEAT tool, Number of Encounters Analysis tool.
That's neat.
And that's in the, thank you. And that's in the ComSpoc, comspoc.com/NEAT. It's another free tool. And what this will tell you is basically what your average encounter rate will be. So if you're looking to put a satellite up in a specific orbit regime, you can actually enter the parameters into a little spreadsheet that's on the website, and it will tell you the number of conjunctions a day you can expect. So you can figure out how many times the klaxon's going to sound for your analysts to be, I got to look at this thing again. I'm getting 5 of these a day, 10 of these a day, 100 warnings a day. You can determine your workload and figure out if that's a good orbit regime for you to fly in.
So if you're very early in your orbit design phase, check it out.
Yeah, that's right. That's
see if it's reasonable in the ballpark,
and
if that's an altitude that you should be using.
And we also run the Space Data Center for the Space Data Association. So we do conjunction assessment there as well. Now that's people pay us to do that. That's not one of the free services. But we take two-line element set data, we take special perturbations data, and the owner data. And we fuse those all together, and we pair them up. So you could have SP on owner, TLE on owner, TLE on TLE, or whatever, and mix and match, and then
use the best possible data.
Right. Actually, we use all the data, whether it's good or not. That's all the pairings that you get, and then from that, the owner can decide what he trusts as far as all those outputs and which one he's living to live with or act upon. And so that's the Space Data Center. One of the roles of Space Data Center.
So some of the satellites that are up there, if they don't have onboard GPS, they rely on ground ranging and the ground station for the position. And their known owner-operator accuracy is probably within the bounds for them to do their mission. But some of them we've found in the ComSpoc, they have biases in the system.
Yes, they do.
And the satellites are sometimes several kilometers further away from where they think they are, which is not a big deal, like I said, for operations, if you're at geo altitude.
Yeah.
But if you are several kilometers away from where you think you are, the close approach, that's a big deal.
Yes. And so if you're talking bias, you've got two things going on. You've got your mean position is wrong, and then the uncertainty associated with the mean position is going to throw you off even further. So we need to get those biases down to zero. And most of the math assumes a zero mean error.
Thank you very much, Sal. It was great hearing from you and your wisdom. I think I'm a little bit smarter now. I hope so. I hope everybody else is too. Thanks a lot. We'll talk to you later.
Thanks, Josh.
Thank you. Here are a few pics of Sal flying, and he logged over 2,600 flight instructor hours, which is a lot by any standards. We are here at the 35th Annual Space Symposium. With me, I have retired Air Force Lieutenant Colonel Dave Vallado. And when you talk about people writing the book, it's a turn of phrase to say, oh, he wrote the book on something. Well, Dave actually wrote the book on astrodynamics, and his book is used by how many organizations do you think adopted your book as their official curriculum?
I've really lost count. It's probably every university that does astro, and there's not a lot, but everyone in the world uses it or knows about it.
But it's not just US, it's all over the place.
It's international, all over the place, and it's really humbling because I started out, I was teaching at the academy, and there were some guys writing books there, and I had rewritten the software for the courses, I had rewritten a lot of the courses and that kind of stuff, and so dumb me, I thought oh yeah, this will be easy. I'll throw a book together, it'll be all set. 4.5 years later, no weekends, no evenings, no holidays, no birthdays, no nothing. It was done, and that's now 22 years ago, which really seems like a long time ago, but it's been a fantastic run. It's humbling when I go to conferences and people come up to me and they say, "Oh, you wrote the book. Can I have your autograph?"
And it's true. It's true. In this case, you did write the book.
And so it's really cool. Or you go to a conference and you go, I recognize that notation, because that was one of the things I tried to do with the book. Is I wanted to have a consistent notation. I wanted to have some derivations in there so that the stuff that I would have to go through and say, wait a minute, a miracle occurs here. I want to know how to get through that point. And you never knew how to do it. And I wanted some of those equations, or at least some guidelines along the way of how you did it. And I think I got the right blend. It's been very successful.
Yes, yeah, and I know you travel all over the whole world supporting universities and talking to students. And the one thing that I've heard from several people is, you're very approachable. So if you want to come down to the booth and talk to Dave, he'll sign your book. Probably, when you sign your name, do you have like a little notation in the way that you sign, like you do in your book? Maybe like a little vector sign over the A?
I'm glad you asked that, because we talked once before. I said some authors, I've met a lot of authors, and some of them will not sign at all. They won't do a picture. They won't do anything with you. I try to be very approachable. I have my email out there. People on my phone. They talk to me all the time. I'm always there. But it's one of those things you get used to, and it's fun to do. And so I don't a lot of people will just sign their name and that's it. I try to write something personal on each autograph. So either it's the event, or if we've talked about something, I try to put that in there, and then I sign my name and I put a little smiley face.
That's the official notation.
That's my little official thing.
That's how
on
you
there.
know it's
little
right.
Smiley face,
That's
And
right.
I actually got that from Sal, because I worked for Sal for a long time, and he did that a lot, so I kind of picked it up. But I've adopted that, and everybody seems to like it.
That's great. That's great. So you went to the academy.
Yep.
You taught at the academy.
Yep.
And then you served a long time before you started writing the book. Before you went back to teach at the academy. What areas of space were you working in the Air Force that gave you so much knowledge to write this book?
I was really blessed, because by going to the academy, I didn't come from a military family. Mm-hmm. My dad was civil service in the Army and everything, but there was no real military in there. Somehow I got into the academy. I'm not quite sure how, but I got there.
I think I know how.
I enjoyed it. I took Astro and I loved it. My first assignment, I was working on the Peacekeeper missile, or as we knew it then, the MX. Mm-hmm. And then Reagan changed the name. What a nightmare, because we had to change all the documentation and everything. But it was kind of cool to do that, because I had studied satellites, mm-hmm. so that prepared me directly to do program management and stage 1 propulsion. Huh? Totally unrelated. But it gave me a side there. I went from there, got my master's in Astro. Then I went to SAC headquarters, and you got to realize this is during the Cold War. Soviet Union was there, still there, and at SAC headquarters, we had the mission. We fight, we win, they lose, and went there, and that was still mostly ICBMs and forum SLBM analysis and that kind of stuff. Then I went to the academy and taught Astro. And so now I've got all these different fields that are kind of going together, and my master's
they're all related.
My master's was on ICBMs and stuff. Yeah, so it was natural. I had a whole bunch of experiences there, and then when I was actually writing the book, I was down in Albuquerque, and I was doing a whole bunch of things down there, space related, and so it gave me the opportunity to get all of the pieces together and to have some real world examples in the book to make it a little bit more approachable. So it all worked out. It was a lot of fun.
So the first time I met you, me and Michael Mkongo were driving up to your house in Monument.
Oh, I remember that.
And I, your reputation preceded you, and I was like, this is the guy that literally wrote the book on astrodynamics.
Yeah.
And we pull up, and it's like, it's pretty out there in the country, and we pull up, and there's this guy on the side of his house in some scaffolding in shorts painting stuff. He's paint all over him. And you're like, hey guys, I'll be down in a minute. So like, I was like, oh, that's the famous Dave Vallado.
Well, you got to do something in the off time.
Yeah, it was funny. It was a interesting interesting way to meet somebody for the first time, and they're 20 feet above you, covered in paint, looking down at you through their legs.
Was I really covered in paint?
You had it all over your legs and stuff, yeah.
Oh,
so, in my memory, I don't know if it's true.
It was probably true.
It's true to me now, so it's fine. So thank you very much for coming here and talking with us today. Thank you for writing the book that will hopefully make all future engineers smarter and better engineers, because we need it nowadays. And anything else?
Awesome. Well, do look out next year about this time. I should have the new edition out.
Okay.
And it's going to be exciting. There's a lot of things that I found that I want to tweak up and get right.
Enhance, get better?
It's going to be a lot of fun.
Great. All right.
Thank you so much.
Thank you. Next time, a little bit more from Space Symposium.